Understanding CMOS and CCD image sensors. Cameras capture what we see with the help of image sensors, the two most common types being CMOS sensors and CCD sensors. These competing technologies have provided camera manufacturers with two different methods for capturing images for the past decade or so. These image sensors are used to produce the digital images during recording. Both types are made of silicon and use similar mechanisms to process images, but each type uses different technology to capture and transfer image signals. And some users find that there can be a significant difference between the end results. A CCD video camera and a CMOS video camera have different processing efficiencies, different qualities, different paired accessories, and are even different prices. Understanding how each type of sensor works and the strengths and weaknesses of each helps buyers determine the technology that is suitable for their video camera needs. Charge coupled device, that is CCD. The CCD video camera has been the go-to sensor since its development. In a CCD video camera, light hitting the image sensor is converted to an electrical signal. This electron packet must then be transferred one pixel at a time through an output node to an image processor, at which point it is converted to voltage. The voltage is then buffered and sent out from the chip as an analog signal. The CCD is small, compact, rugged, and consumes a low amount of power. Camera tube has been replaced by a special chip, a semiconductor image sensor. This image sensor is called a CCD, that is charge coupled device. In a CCD sensor, the light, that is the charge that falls on the pixels of the sensor, is transferred from the chip through one output node or only a few output nodes. The charges are converted to voltage levels, buffered and sent out as an analog signal. This signal is then amplified and converted to numbers using an AD converter outside the sensor. The CCD technology was developed specifically to be used in cameras, and CCD sensors have been used for more than 30 years. Traditionally, CCD sensors have had some advantages compared to CMOS sensors, such as better light sensitivity and less noise. In recent years, however, these differences have disappeared. The disadvantages of CCD sensors are that they are analog components that require more electronic circuitry outside the sensor. They are more expensive to produce and can consume up to 100 times more power than CMOS sensors. The increased power consumption can lead to heat issues in the camera, which not only impacts image quality negatively but also increases the cost and environmental impact of the product. Used for a number of years in video and still cameras, CCDs long offered superior image quality to CMOS sensors with better dynamic range and noise control. To this day, they are used in budget compacts, but their higher power consumption and more basic construction has meant that they have been largely replaced by CMOS alternatives. They are, however, still used in medium format backs, where the benefits of CMOS technology are not as necessary. CMOS, complementary metal oxide semiconductor image sensors. Digital cameras have become extremely common nowadays, as it is affordable too. One of the drivers behind the falling prices of digital cameras has been the introduction of CMOS image sensors. CMOS sensors are much less expensive to manufacture than CCD sensors. With more functionality built on chip than CCDs, CMOS sensors are able to work more efficiently and require less power to do so. and are better suited to high-speed capture. CMOS chips have several advantages. Unlike the CCD sensor, the CMOS chip incorporates amplifiers and AD converters, which lowers the cost for cameras since it contains all the logics needed to produce an image. Every CMOS pixel contains conversion electronics. Compared to CCD sensors, CMOS sensors have better integration possibilities and more functions. However, this addition of circuitry inside the chip can lead to a risk of more structured noise, such as stripes and other patterns. CMOS sensors also have a faster readout, lower power consumption, higher noise immunity, and a smaller system size. Unlike CCD sensors, CMOS sensors have circuitry at the pixel level. This means that every pixel on the sensor is read and transmitted simultaneously, preparing voltage for the chip. The chip then uses additional technology such as amplifiers, noise correction, and digitization to convert the voltage to digital data. This means that CMOS sensors do not require a separate image processor. Because CMOS sensors are able to convert visual information to digital data more quickly than CCDs. They require less power, which preserves battery life. However, the extra technology on the sensor crowds the pixels, limiting their ability to capture light and resulting in generally poorer visual clarity in the final image. CMOS sensors are commonly designed with rolling shutters, especially on commercial applications. This means that the image frame is exposed from one side to the other, instead of all at once as on CCD sensors. For example, a video camera using a CMOS sensor may record data in a rolling sweep from left to right or top to bottom. This results in the potential for a few types of distortion not found on CCD sensors. Since their inception, both types of sensor technologies have landed in a wide range of cameras, but CMOS sensors seem to be increasing in popularity. The Red Epic's new Dragon sensor is actually a 19.4 megapixel CMOS sensor capable of shooting up to 6K.